Okay, so you got yourself a new old gadget. It doesn't necessarily need to be an amplifier. It can be a radio. It can be anything with knobs. And you want to get the knobs off. Now, in the case of this amplifier, I had to get this knob off. This control was extremely tight. On the inside, it looked like at some point in time, somebody probably spilled something. A little bit had gotten down into one of the tube sockets. But this knob here, actually these two knobs, the set screws in these were a block of rust. Now, I know everybody's tempted, just slap the screwdriver in there and turn as hard as you can. I can tell you from experience, you're going to strip the screw out. And once you do that, the only thing you can do then is drill the set screw out. And you're making a lot of extra work for yourself. A lot of times you can get them out, even if they're seized. And I mean really stuck on. Now, this top one, I just sprayed a little bit of penetrant in there. Now, what I use is actually a gun cleaner, Z-Rust. They make really good products, But I just sprayed a little bit of that in on the, both the holes. Where the hell the hole's at? There it is. It's over there on the side. Sprayed a little bit in the holes and let it set overnight. Come in today. I came in with a screwdriver that was too small. Now, here's the key to getting these things out. Get a screwdriver that's too small, or a pick. Like a dental pick, something that's smaller than the actual slot in the screw head. What you want to do is move it back and forth. You want to try and break up that rust. In other words, you want to clean out the screwdriver slot. Because that's the problem, is when you stick a screwdriver in there, even if it is the proper size for that screw, well, if the slot that the screwdriver is supposed to go in is a block of rust, you're only getting, let's say we were looking at it under a magnifying glass, the screwdriver slot's this deep, magnified. Well, if it's full of rust up to here, then the screwdriver's only making contact in the very tip top of it, and you're going to strip the head out. And, you try and dig in a little bit farther, and then you just strip it down a little bit farther. And eventually you're left, then you have to do a true extraction, drill out the set screw, and then you stand a chance of damaging threads. And, if it's an easy-to-find knob, it's one thing. If it's something like this, these are kind of oddball knobs. It's, not a very common knob. They're found on other stuff, but it's not something, I can just, the average person's going to be able to just turn around and go, just pull one out of a drawer. So, whole key here is take your time. Like I say, start with some penetrating oil. Pick a good penetrating oil that's good at breaking down rust. Let it set overnight. Don't be in a rush. The equipment's not going anywhere. It's not hurting anything like this. So, come in the next morning. Like I say, clean out the channel for the screwdriver. Once you have it cleaned out, apply a little bit more oil to the set screw. Now, this top one, I was able to get out. I was able to come in with a proper size tip. That's the whole key, proper thickness and width. And I got that set screw loose, and I was able to just pull this knob right off. Now, this bottom one, I had to work on it a little bit more because it was really rusted up. But I did get the set screw finally removed. But then the knob was stuck on. I couldn't get the knob off at all. It just plain stuck, period. It was not coming off. So I actually came in with a screwdriver. Now, the trick here is, if you can, take something with a fairly large tip. You want to try and catch it on the flange, or on this nut here, okay? So what you're doing is prying up on the underside. Try and get up in here. You want to ideally try and pry on here, because if you pry on this outside part, you stand a chance of chipping or breaking that off. Now, sometimes that's the only option you have, but I was able to get the knob portion itself off. Unfortunately, the brass part that actually goes down in here is still stuck on the shaft. And yes, once I got this part of the knob off, I was easily able to see that, yes, definitely something was spilled on this thing. It's green, it's crunchy, and yeah, it just wasn't looking good. So again, come in with the oil. I sprayed it on there, let it sit for about an hour. Now, the advantage of this is I now have access to the end of the shaft. So I tried a two-jaw puller, very small one. I have pullers up to, my largest puller is a 150-ton OTC. Yeah, I used to be a tractor-trailer mechanic years ago, so yeah, I've got pullers all the way from model train, tiny model train pullers up to, 150-ton pullers. 2, 3-jaw pullers, bearing splitters, you name it, push pullers, T-bars. I literally have a 3-drawer Snap-on toolbox That's the only thing that's in the entire toolbox. Pullers. Hundreds of them. So, in any case, so yeah, I tried that, but you're only catching, of course, the outside edges, and it's a round shaft, and it just popped off. And I don't want to strip this, because this is actually knurled or fluted on the outside. It's meant to, it was originally pressed into this, okay? Now, this isn't actually slotted. I don't know if you can catch it in the camera, but you can see there's some little grooves down in there when that piece was actually pressed in this when it was made. So the next thing to do, the advantage we have here is these are usually not steel. They're usually brass. I have seen some aluminum, that's kind of rare, but usually in the older knobs, this metal insert that is threaded, because that's actually what has some of the threads in it, there's the hole where the set screw would go in. But it's actually brass. That's a big advantage for us, because that's brass and it's a ring, and brass expands. Has a very high expansion rate, just like aluminum. Most of your soft metals, actually, when you heat them up, they get bigger. All metal does, but brass really expands, and it takes heat really well. So, now usually, of course, the shafts are also a lot of times brass. But what we want to do is apply a little bit of heat to this ring. So that's exactly what I did. Now, I've already gotten it loose, but all I did to do this, I just pulled this out a little bit past the bench, just wiped off the oil that I had on there, came down with the torch, and just lightly heated that, like 2 or 3 times like that. I just heated it a little bit, turned it around, heated it, turned it around, heated it just a slight bit. Then I just came in from the back side, again, keeping the screwdriver on the face of that nut, because we don't want to damage the faceplate. And if you feel you're afraid you're going to slip off, I usually try and get finger here, so it's kind of impossible. But you could always put a couple layers of tape, hold a pack of Post-it notes here or something, up while you're prying. But like I say, get the screwdriver on the flat of that nut, and then twist it. And I can see that one's starting to move. I actually had it out a little bit farther earlier. And that's another thing you'll see. I kind of hold it sideways, so if I slip away from the faceplate. I'm not in at an angle like this, where if I slip, I dig into the aluminum faceplate. Try and hold it at an angle that I'm not going to damage anything should I slip off. And actually, it looks like, there we go, and it's off. So, and you can see how grungy that is. All the green from the corroded brass. But now I have it off. I can just clean that up with a little bit of sandpaper, smooth it off, clean the center of the insert out, then clean everything off with isopropyl alcohol. Put a very, very tiny amount of epoxy. You can use any type of glue. Super glue would work, anything. But a little bit of glue in here, and then I'll press the insert back into the knob, and I'll be good to go. Here was the set screw I'd already removed. That's not going to focus on it, is it? There we go. You can see how rusty it was, but I was able to get it out without stripping, and we lost focus again. It just doesn't like this little tiny stuff. But I was able to get it out without stripping it. So, like I say, just be careful. Don't be in a rush when you're doing stuff like this. Especially on, in the case of this, it's a customer's, it's not mine. So I definitely don't want to damage it. But there's just a few tricks, like I say, penetrating oil, penetrating oil, penetrating oil. Soak time. You can use the best stuff on the planet if you don't let it, because you have to remember, this thing was seized, and you want to let the same thing with the set screw. You just spray some oil on there. Don't expect it to wick down in instantly. The rust is filling it. It's almost what would you call that? Like a hydrostatic or hydraulic. It's bound in there. It's extremely tight. So it takes a while for the oil to soak down through that rust and get down in there, and then start to break it up. So, like I say, time. But if you ever get stuck with an insert that's stuck on the shaft, gets pulled out of the center of your knob, never fear. That's actually fairly easy to get off. Just a little bit of heat from a torch. Doesn't take a lot. You don't need to get this thing glowing. You just need to hit it a couple times with the center part of that flame, the hot part. That really right there, at the point of the tip. That's the hottest part of the flame. Just hit it 2 or 3 times with that, just for a split second. It'll heat this up. That's the thing. You don't want to heat the shaft up. You just want to heat this outer collar up. It'll expand. You can get in there, and usually you can break these loose. So there you go. There's just a quick tip on removing stuck knobs and knob inserts. And yeah, you thought it was the end of the video. Well, as soon as I got that actually off and I turned the control, this is a common problem. So if you run into this, don't be afraid. You think, oh crap, I just destroyed my control. Is when you pull out on this shaft, there's what actually holds tension on these air variable capacitors. It's kind of hard to see back in here, but yeah, you can just barely see it. This actually is a tab that you could solder to, but there's a little arm goes up. It's it's got a hole in the middle. Another little leg comes down there, and there'll be one on the other side. But there you can see that's at an angle right there. Okay, what they do is they hold pressure. They push basically against the ceramic part here, and then push back on the shaft. So that gives it tension. Because right now the problem is when you turn it. Now just watch the plates in there when I let go of this. Yeah, it went from being really, really hard to turn to, yeah, it's so loose now that it's absolutely useless, because you would turn this if anywhere other than if it's at the bottom of its rotation. Anywhere else, it's just going to rotate on its own. So, but never fear, this is not a big problem. All you need to do is get a piece of, now, personally what I'm using is back in, well, actually they still call it that, but it was popular back in the tube era for insulation board. Actually, I used some of it down here, make a little insulating shield in the 120 volt area, the line cord area. But it's called fibroid or fish paper, and it's an insulating material. Okay, just thin, but it's an electrical insulation. That's what this is actually meant for. It's an electrical insulation board. I just cut out a little tiny piece of it, because I've run into this problem several times over the years, prying old stuck-on knobs off of air variable capacitors, and had this exact thing happen. Because when you pull out on that shaft, you bend these little tabs that are actually holding pressure against between the ceramic and the plates, and it loosens up. So we need to, and there's no way you're ever going to get in there, even if you remove the control, you're never going to really be able to retension those, but it's an easy problem to overcome. And all you need is this and a little tiny dot of glue. Because what you're going to do is stick this in between one of those little ears that come down. Okay, and if you watch, matter of fact, watch that one, because that's got the long arm attached to it. It actually has a solder leg. See how that actually springs? It's getting pushed back a little bit. And that's all you need to do. You just need a little. And now the control turns, still turns without hanging up. But as you can see, it no longer rotates on its own. So I've applied a little bit of pressure, and then of course the other two fingers, they've been pushed in at an angle a little bit. But so what I'll do is, I'll just cut off a little tiny piece, about that long. I'll put a little tiny dot of glue on the one side that's touching the ceramic insulation port here, or part, and just shove that in with a pair of tweezers. Problem solved. So the control has been, the stuck knob was taken off. The shaft freed up, actually really free, way, way, way too free now. It's self-turning. And, like I say, all you need to do is just put a little bit of tension on one of those fingers. And so it's just a matter of just sliding a little piece of insulation board up in there. I can get around the camera here. Like I say, just to basically stick that in there. That applies tension. It's good as new. It turns, it holds, does exactly what it's supposed to do. It's a piece of insulation board, so you don't have to worry about shorts or anything. It's not going to affect, the capacitance of that. So there you go. There's just a little thing if you do end up screwing up your air variable capacitor. If it happens to be an air variable capacitor you're trying to, pry a stuck knob off of, that's just something to be aware of. And that is a quick fix to a common problem you'll run into with that.